Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn all about dynamic in C#. This is a really interesting feature of C# that allows us to write code against a type that doesn't actually exist. Okay, so here let's see the dynamic keyword. Now this is a very special, very unique thing. We use it kind of like defining a variable. So we write dynamic, and then we give it some kind of name. Let's say just D. If there it is, with this we have defined the variable D, and it's of type dynamic. Now what dynamic means is we don't actually know what type this is. The type will only be defined at runtime. That's very important. So this is somewhat similar to var. So for example, if we say var v equals something, if we do this, we also don't specifically define a type. However, var, this one is being evaluated at compile time. So when the code is compiling this line, it looks at what comes after it and infers the type. So when it comes to runtime, var doesn't actually exist. When it comes to runtime, var is replaced by an int. Whereas over here with dynamic, at compile time, we still don't know what type this is. We're only going to know at runtime when this code actually executes. So that also means that within this type, we can do anything we want. For example, let's say this type is a new object, something like this. And then over here, we can call whatever we want. So we can call some kind of test function. And if there's no error, we can access some kind of field and do something. And if no error, that is because, again, right now, we have no idea if this is right or wrong. Maybe when this code actually runs, maybe the object that is inside of this one, maybe that object does have a test function, or maybe it doesn't. For example, in this case, it will not work. Here we construct a brand new object of type object, and the object type does not have anything called a test function. So if we try running this, and if there it is, we have an error, a runtime binary exception. It is saying object, the type object, does not contain a definition for test. So you can write whatever you want after this, you can write whatever function name, field, property, whatever, and you won't get any compile time errors, but during runtime it will check, and if it does find some function or some property with that name, then it runs it. If not, then it throws that error. This is the really important thing about dynamic. It is how it only runs at runtime and not at compile time. During compilation, it assumes that whatever you did with this dynamic object, whatever you did is correct, it is what you wanted to do. Only in runtime does it actually try doing something, and if it can't, then it throws an error. So in order to see a positive result, for example, every object always has a toString function. So if we run this, if there you go, the program runs, no errors, everything's fine, because again, toString does exist within the object. But we only saw that during runtime. So now with this, you might be wondering, where exactly is this useful? It does seem a little bit strange. I mean, right here, if this is what we want to do, then naturally, instead of making this dynamic, we would make an object. And that way we can't write something like this, we get a compiler error. So if you want to do this, and obviously using dynamic doesn't make any sense. If you know the object type, then just use the object type. However, where this is particularly useful is when dealing with something like JSON data from a web server. The data schema might change over time, so you might not be able to define the exact type over here. For example, here we have some simple JSON. So it's just an object, inside it has an assets, and this asset is actually an array, and within the array it has 3 separate objects. Those objects have a type field, a name field, and a path field. So let's say, for example, we receive this JSON from some web server, like for example, maybe some modding site, and this is the data that we need in order to install our mod in our game. Here with the JSON, now the first thing we do is convert it into a dynamic object, and one simple way to do that is with the Newtonsoft JSON library. That's the most popular, very capable JSON library. In order to install it, let's go over here on the Solution Explorer. Let's right-click on the project itself. So not on the solution, right-click on the project. And then down here, let's go into Manage NuGet Packages. And up top, just go into the Browse tab and then search for JSON. And there it is, the main one, Newtonsoft.json with 5 billion downloads. So yep, let's go ahead and install this one. And then with that package installed, over here we can use the class JObject, which exists inside of this namespace, Newtonsoft.json.link. We can use this and we can call the parse function. This one takes a JSON string and returns an object. So let's parse our JSON and let's put this inside a dynamic object. So dynamic, let's call it JSON dynamic. And yep, just like this. And now here we can do whatever we want inside of this object. So for example, we can go inside of this one, we can access the assets. And again, note how we have no auto-completion because once again, dynamic does not know what type this is going to be. So let's make sure to write it properly. So assets, and assets is going to be an array. So let's access the first element on that array, and then let's just access the type. So it should be this one, it should say texture. So this, let's put this inside a console.writeLine. Let's print out this and see exactly what it says. And if there it is, it does say texture. All right, awesome. So you see how here we define some structured data, but we have no class, no struct, we have no actual type defined that matches up this structure. But thanks to dynamic, we were able to load it onto a dynamic object, and then we were able to go inside it, write all the names for all the properties and get whatever data we want. So it works perfectly fine for accessing something, but if we access something that does not exist, let's say, for example, that we go on assets instead of assets, let's call it asset, which does not exist. Yep, of course, we get the same error. So if we want to test if a dynamic object has a certain function or property, for that we have two methods. So one option is using reflection. So we can go through JSON dynamic, we can call getType. This is going to return our type for this, and then we can call getProperties. And yep, we get an array of property info. So the same as with any other type of reflection. You can watch a lecture on reflection for more on this method. Or another alternative is to simply try to access it. So for example here, let's try reading this. So string for the type name. We read this and we read inside of asset, which does not exist. And if this one naturally throws an exception. So this is how we can test it. We can put this inside a try catch. And let's catch for that one. Catch for a runtime binary exception. And if it happens, then that property does not exist. So you can do this to go one by one throughout your dynamic type in order to figure out what exists inside of there. Then dynamic can also be a return type of a function. So here, let's do something and return dynamic, some kind of test function. And then here we can return whatever we want. So we can return an int, we can return a boolean, we can return a float. All this does work. Or we can even actually return an anonymous type. Yep, this is perfectly valid code. By the way, I cover anonymous types in another lecture. And then up here, we can simply call test and grab whatever returns from there. Then inside that one, we can access, for example, the name. Let's do console.writeLine. And if there it is, and does work perfectly. Now, before we end this lecture, let me also give you just one quick tip that is somewhat related. It's related to JSON here. Like I said, the goal with dynamic is that you don't know exactly what the schema is. If you don't know that, then use dynamic. But if you do know, so if you know your JSON is always going to have this format, if so, then you should create an actual class with all of this data. But doing that by hand is actually quite tricky. You would have to write some kind of class, call it JSON data. Then you would also have to define another class for something like asset single. Then on this one, you define a string for the type, the name, and so on. So you can write it manually one by one, which when you have some complex JSON, that can actually be quite laborious. Or alternatively, Visual Studio actually has a super simple, super helpful answer. You just copy your JSON, the JSON that you receive from whatever web server, whatever you have, just copy it onto the clipboard. And then up top, go into edit, then let's go into paste special, and paste JSON as classes. And if there you go, it automatically creates this. So it creates our single asset that has a string name, path, and so on. And if these were Boolean or a whole number, then it would change the type here. It would not make it all string. And then for our root object, so that's the main object, just has an array of assets. So you have just a quick tip when dealing with JSON. If you don't know the data schema, then use dynamic. But if you do know it, then use that in order to get the actual type and then work with it with the actual type. All right, so that's dynamic. It's a really interesting feature of C# for working with types where you don't really know what the type is until runtime. This is super useful when contacting something like a web server and getting data without knowing the schema beforehand.